basically you take a point in space and then you draw lines all the same distance from that point. Connect all your dots and the end result is a sphere. That point is called the center. Just like in a circle, center of the circle, same thing. And radius and diameter, same as in a circle. The only thing is, of course, a sphere is three-dimensional, whereas a circle is two-dimensional. Okay, so we also have something called the great circle, which is not related to the great pumpkin.
What?
Ooh, good player.
What? So a great circle is okay, can somebody name a great circle that they're aware of?
Did you say grape or great?
Great. What? A great circle? What is a great circle?
A great circle.
So we have a sphere, and then we have a circle that goes around the center of the. They have cut ball as a sphere, but if they're one particular, Saturn had rings outside the circle.
Universal.
The universal thing.
But,
Okay.
again, these are all excellent examples of spheres. Yes, I get it. But can anybody think of a particular circle that is the great circle of a particular sphere? How many? Earth. Good.
The equator.
Great circle.
Oh yeah, that.
The equator goes around the center of the Earth. Now,
Isn't that the universal thing?
I don't know, but it's not a big. If it is, it's because it's the equator. Anyway, the circumference of a great circle is the same as the circumference of a sphere. And then, if you have a great circle that divides your sphere in half, each of those halves is called a hemisphere. Hemi meaning half. Just like here on Earth, we have the northern hemisphere and the southern hemisphere because the equator divides it in half. Okay, so the surface area of a sphere is very simple. Pi r squared is what? Pi r squared is the what of a what?
The area of the
It's the area of the circle. And what basically if you took a sphere and you opened it up, what you would get is 4 circles. Divided up a sphere into 4 circles. And that's why the surface area is simply the area of one of those circles times 4. So simply put, you find the surface area of the circle on the sphere on the right. It's 4 times pi r squared. If my diameter is 10, what's my radius? 5. So I get 4 times 5. 4 times pi times 4 squared, which is 4 times pi times 25. 4 times 25 is 100 pi meters cubed. So this one says leave it in terms of pi. Okay. All right, so problem example number 2 is a little more complicated because, well, why? Why is it more complicated? Riley, why do you think problem number 2 is more complicated? Besides the fact that I just said so.
Because it gives you the wait.
It tells you the equator, so that tells us the equator is what? The great circle. So the equator is actually the circumference of the circle. So they're not really telling you the radius if they're giving you the circumference. So the reason this problem is more complicated is because we have to kind of deconstruct the circumference to find the radius. So the first thing we need to do is understand the formula for the circumference of a circle. Does anyone remember that? What is the circumference equal to?
Or
What? How many pi r?
or
2 pi r. Now I could have also used pi times d. Because the circumference is also pi times the diameter. What's the advantage of using 2 pi r instead of pi times d? Why is it easier?
the step.
Why is it fewer steps? What do we need in order to find the surface area?
Diameter.
We need the radius. So if we first leave this as pi times d, it's an extra step because we're only going to have to divide by 2. Alright, so they give us the circumference. So we have 24,902 is equal to 2 pi r. Now to solve for r, what are we going to divide by? 2 pi. So we divide both sides by 2 pi. So we get that the radius is equal to this. Okay, do not simplify this. Why should I not simplify this? No. Is this the end of the problem? Am I being asked to find the radius? But round what? What are we looking for? The surface area. So we're not looking for just... Since we're not... This is not the end of the problem. If we were to actually figure out what the radius is, we would get a decimal approximation. We don't need a decimal approximation. We could just plug this right into the formula, which is what we do. Surface area is 4 times pi times this. Actually, you know what? The book does plug it in, but I don't think you need to. But you can if you want to. The book does. So if we do 24902 divided by pi, you get that. I'm sorry, 2 pi, not just pi. Try that again. 24902 divided by 2 times 4902 divided by parentheses 2 times pi close parentheses gives us that. Now, if they don't tell you how far to round, go out 4 digits. 4 digits will be enough. So we get 3963.2764. 4 digits will be enough of a rounding so that it won't impact your final answer. So now we have 4 times pi times that 3963.2764 squared. Again, just plug this into your calculator. And you get that. 197,387,017. And then 0.47 rounds to 0.5. So it's that's your answer. And the question asks you to round it to the nearest 1,000 square miles. So here's my 1,000th place. So what should my final answer be? This is my 1,000th place. What should my final answer look like? Anna. This is the answer I got from plugging in the calculator. But the question said round it to the nearest 1,000 miles. So what is this rounded to the nearest 1,000 miles? How many zeros should my problem have? Give Anna a chance. Question doesn't say round it to the nearest 1/10 of a mile. It asks us to round it to the nearest 1,000 square miles. So that, to me, that's going to be an important part of this question, is being able to round. It's not a number that we're used to rounding to. My question is, how many zeros, or how many places should I replace with zeros? In fact, what should be the last number in this answer before the zeros? 3 zeros, that's right. So what's the last non-zero? Very good. That is the answer. So the surface area of the Earth is a little more than 197,000 square miles.
Is that real?
Yeah. 'Cause that's really about how big the equator is. Okay, does anybody have any questions about surface area? Okay, let's go on and talk about volume. Since volume is three-dimensional, we're going to take, you notice it's the same formula, 4 pi r. Instead of it being squared, because we're dealing with 3 dimensions, it's cubed, so it's 4 times pi times r cubed, and then that is going to be divided by 3. So to solve the volume, 4 times pi, my radius is 6, so I take 6 cubed divided by 3. You can just take that and put it in your calculator. So 4 times pi times 6 to the 3rd power equals 4 times pi times 216 equals, divided by 3 equals 904. Did I write down 4/3 pi r cubed? Oh, I see what I'm doing. Question said put it in terms of pi. Sorry. So it's 216 times 4 divided by 3. Okay, what? Yes. Because that's the formula. 4 pi r cubed divided by 3. It's actually 4/3 pi r cubed. But it seems easier to me, especially if you're using the calculator, to do the multiplication first and then just divide by 3. You don't multiply by pi. So just multiply, just do the math of the numbers and then put pi at the end. If they ask you for it to the nearest whatever, that's what you then add to pi and multiply this pi. Okay, does anybody have any questions about surface area or volume? Okay, we have about 10 minutes remaining. I have 3 problems up on the board. Please do as many as you